All right, this is Dr. Darbro. Again, I'm creating the course. You may not take the course from me, but I presented all the instructional videos and all the course content. Let's talk a little bit about the co-requisite remediation component. Now, typically, I think the way to motivate this is to think about what's the difference between Stat 1800 and Stat 1800A, which you're currently in. So using ACTs, high school GPAs, and a variety of other metrics, we determine students who are prepared for 1800 versus not being prepared for 1800. So by not being prepared, we've decided that you probably need a brush up on some developmental math content. So typically what would happen is the student would take Math 0101, which is our developmental math course that leads into Stat 1800. So in one semester you would take this class, which is 3 credit hours, and the next semester or a semester after you would take Stat 1800, which is 4 credits. So you would spend 2 semesters and you would pay for 7 credits. Now, this Math 0101 has all these objectives, and I say 28 objectives. I don't know, maybe it's 29, maybe it's 50. But I will tell you that not all of these objectives are needed to be successful in statistics. So what we did is we went through here and we pulled out the ones that were needed and we focused on those. So then we crunched all this, so to speak, into one class. And we use this catchphrase called just-in-time remediation, which means instead of teaching this content in a semester before, maybe even a year before, maybe 5 years before, when you have a chance to forget it, we teach it just before you use it. Okay, so what we have as a result is we have Stat 1800A, which is a 5 credit class, which is taken in one semester as compared to 2. And instead of paying for 7 credit hours, you only pay for 5. So I hope that makes sense, the motivation for co-requisite remediation. Shawnee State was one of the, actually with the kind of the pioneers, if you will, in Ohio, back in I don't know, quite a few years ago. So I wrote a grant and we investigated it and found out it actually works. So here we are. All right, so for the first lesson, this is the content that I have decided is important in you being able to succeed in lesson 1. So this assignment is uploaded in Blackboard. And to save time, I've just gone ahead and worked out the problems, and I'm just going to run through and highlight what I actually did, how I solved these. Again, it's in the spirit of the just-in-time remediation, and it's also in the spirit of trying to keep the videos as brief as possible. So the very first thing I think we need to review are adding unlike fractions. So if we look at a half plus a 3/4, the very first thing we need to do is think about getting an LCD. Well, the lowest common denominator of 2 and 4 is 4. So that's the smallest number that 2 and 4 both go into. So I create equivalent fractions. So both of these will have a 4 in the denominator. And since I multiplied 2 by 2 to get 4, I multiply the 1 by 2 to get the equivalent fraction of 2/4. I add the numerators. 2 plus 3 gives me 5/4, or 1 and 1/4. Now, if you need more work on unlike fractions, there are millions of hits through a internet search. But again, in the spirit of trying to keep this relevant to the skills needed to be successful in statistics, which is what our focus is, I can't go too deep into the weeds on adding unlike fractions. So let's take a look at this. 5 2/3 minus 1 3/4. What I do there is I do the reverse C. So I take 3 times 5, which is 15 plus 2. So I get 17/3. Do the reverse C. 4 times 1 is 4, plus 3 is 7 over 4. I have denominators of 3 and 4. The smallest thing that 3 and 4 both go into evenly is 12. So 4 times 3 is 12. So I take 4 times 17 to get 68. 4 times 3 is 12. So I take 7 times 3 to get 21. So take 68 minus 21, I get 47 over 12, equivalent to 3 and 11/12. This one's a little more challenging. 5 minus 1 and 3/4. What I need to do, because I have a denominator of 4, I need to create my 5 with a denominator of 4. So again, let's start with this term, do the reverse C. So 4 times 1 is 4, plus 3 is 7 over 4. That's where I get that term. And then I need to create a fraction that has a denominator of 4 that's equivalent to 5. Well, we should be able to see that's 20 over 4. So 20 minus 7 is 13 over 4. Order of operations. We see these all the time on social media. Now remember, please excuse my dear Aunt Sally, which says we do the parentheses first, exponent second, multiplication, division next, moving from left to right, and addition, subtraction next, moving left to right. So the first thing I would do here is do the multiplication, which is 4 times 3 is 12. So 5 minus 12 gives me -7. Now in your co-requisite assignment in my stat lab, I've chosen these problems because they mirror, they're very close to the problems you're going to work in that assignment. All right, second page. We often in statistics have to use our calculator to evaluate a square root. So if I'm going to do something like that, I would just go square root 47, and I would get 6.8556546. I think the instructions say to round to the third place. Is that correct? Yeah, round to 3 places. Because this is important, because that's the kind of situation you'll be put into in my stat lab when you're entering your answers. So what I do is I come over to the third place. I focus on the next digit. If it's 5 or bigger, I round up. If this would be 4 or smaller, I would leave the 5 as a 5. So I need to round this up. So the answer would be 6.856, as I've noted. Evaluate expressions. We get into really more and more complicated versions of this as we go through the class, but for right now, I wanted to choose something a little, I guess, slightly more straightforward. So I would square b. So b is 3, so b squared is 9. Then I would have -4, and then I would multiply a times c. A is 2, c is -4, so -2 times -4 is 8. Same logic before in the previous page. I need to multiply first. So I have -4 times -8 is 32, plus the 9, add these, square root of 41. Square root of 41 does not have a perfect square, so I would just leave it in that form. Another thing we run into a lot in statistics is working with summations. Now, some students, and again, I've taught this class so many times, I think I'm north of 125 times now, which is kind of insane to think about. But students lose their mind when they see this summation. This should be thought of as nothing more than you're just going to add up a bunch of stuff. It gets a little more complicated, but in its principal form, it just means add up stuff. So this tells me summation x, add the x's. So you can see that I put the 1357 in a column. So when I add these up, I get 16. So the sum of my x's is just 16. This is a little more challenging because this says I need to square my x's and then sum up the results. So if I square x, 1 times 1 is 1, 3 times 3 is 9, 5 times 5 is 25, 7 times 7 is 49. If I sum these numbers up, I get 84. That's different than the sum of x quantity squared, because that tells me that I need to do what's inside the parentheses first. So sum up the x's, which we know is 16, and then take the square of that, which is 256, because 16 times 16 is 256. This one's a little more challenging. Again, I need to do what's inside the parentheses, so I need to create a column of 12 minus x's. So if x is 1, 12 minus x is 11. If x is 3, 12 minus x is 9. If x is 5, 12 minus x is 7. Sorry, this is redundant. And 12 minus 7 is 5. Add these up. 11 plus 9 is 20, plus 7 plus 5 is 32. So the numerator, the sum of the 12 minus x's is 32 divided by n. N is always the number of elements in our data set. So 1, 2, 3, 4. So 32 minus 4 is equal to 8. So I hope this provided just a brief review. You'll get a chance to practice these in the co-requisite assignment in my stat lab. So I hope this helps, and circle back on some stuff that you've probably seen somewhere previously in your math classes. All right, that's all I got.